In this video, we introduce types of machine learning and aspects of successful machine learning problems. There are three main components to machine learning, and they are data, computational power, and algorithm. So one of the things that makes machine learning so popular, a technology that's being adopted currently in many applications, is the efficiency of these algorithms to gain insight from data with very little to no effort in terms of programming. You know that phrase of learning from my mistakes? That's what, as humans, we say that often. Well, that part of learning from mistakes, learning from errors, it's fundamental. So machine learning algorithms require some history of experiences to be able to learn from mistakes. So, for example, one instance in which machine learning algorithms are used is, think of how your smartphone may unlock based on the shapes or specific features or patterns of your face. So that belongs to a class of machine learning algorithms that specialize on basically using large amounts of data to come up with the decision whether or not to unlock the phone. So in this context, large amounts of data is necessary. So we're talking heavy volumes of data, and the way to implement these algorithms is with having compute power, and not any compute power, but compute power of virtual computers in the cloud. And so this type of compute is going to be a useful tool for carrying out calculations. Think of, like, I don't know, computing eigenvalues and eigenvectors and singular values. Perhaps also browsing or examining in a lot of detail large amounts of data with algorithmic steps, and making predictions at a really fast pace. These are all tasks that are well suited for virtual computers in cloud environments. I mentioned cloud environments because those environments will have architectures that are designed, built, and deployed to optimize speed and efficiency. So a little refresher: tabular data is going to be data similar to the data similar to the data structures we learn in linear algebra that we call matrices. So a matrix is basically a table, and here tables probably are more powerful because, well, tables are going to have two dimensions, rows and columns. The rows are going to represent like a snapshot or a sample of the data, and the columns are called features. The columns are going to be associated with statistical variables, whether they are quantitative or categorical, but there is one column that is not considered a feature, is going to be considered the label or target. So using some notation here, it's common to use the letter X to denote how we store the features. The features are columns, and we may say that there is a matrix that is storing columns that may have indices like x sub 0, x sub 1, x sub 2. So each of those x sub k is a feature, a quantitative variable, and we may store them all or stack them into a rectangular matrix that we may call the feature matrix. And then there is one column not part of X, which is going to be denoted with the letter Y, and that Y variable represents the response or the target or the label data. So besides tabular data, there is another type of data that has to do with images. Images exactly, I go back to the motivation with the smartphone. With your smartphone, you may take photos of a lot of things or a lot of people, or a lot of situations. So when you produce a photo with a device like a smartphone, that usually is stored into a file. And what you see on this slide is in the middle column, the extension JPEG, JPG is the type of a common type of data extension, common type of file extension for an image. There are other extensions, but just to make an association here, so each data sample would represent an image that's stored as a file. Here there are features also. The features they're going to relate to the pixels and any relationships the pixels may have with one another. And the label for this type of data may be what is the the main shape that's stored there. Maybe is an animal, or if it's an animal, we may refer to as a species. Maybe is a plant or a flower or a tree or something of that sort. So the labels has to do with what's represented by that. So let's consider here those images on the screen are of an animal, a specific species. This is a raccoon. Not that that's the only photo, but that photo that just appeared here with a frame or some kind of box in color blue, it's actually also depicting the label for this image. And then let's see what we have next. This is information the machine learning algorithm would use to treat the pixels that are representing a raccoon or a typical raccoon. It would treat those as features, and those this is exactly almost in a literal sense of what we would say features or traits in terms of how something looks like. So like shapes, round, square, or like exactly as in that sense. And then an algorithm of the machine learning domain would use that to train models. So we have talked about data that has the shape of a table. We've talked about data that has to do with images, and then another family or domain of data has to do with, this we would call in Python the data type string, right? But text in general, text, words, concatenations of words, characters that put together define a word, and then there are rules for grammar in a specific language. So let's just think of data that specifies messages or phrases, sentences, paragraphs, things of that sort. That's considered a text data type. So this is what we're discussing last here in this debrief. An example of a text data set may be as short as just what you're seeing on the screen, which is a phrase. But it may have multiple phrases. It may have the structure of not phrases but sentences grouped together into paragraphs, and it may be a document with multiple pages with more data points, if you will, of this type. So just to kind of wrap up, data sample will be a unit or a segment of text that's stored into a file. The features are characters, text characters or words, and a label. It's something that maybe you have heard, sentiment analysis. Does the text express something that's positive, something that's neutral, something that's negative? in the negative, neutral, or positive in the sense of how we use language. So for text data, this is what machine learning algorithms are used for. We'll use those algorithms to know whether a text is positive. Perhaps the text is a review. Okay, and here's what we see on the screen is an example of somebody that wrote something about a book. Okay, now the process of how the algorithm is deployed is kind of summarized here in a couple of schematics. First, you would take the data, and what you're seeing there in the box, in the rectangle in the middle, is that the data was kind of broken into smaller pieces of data. So we started one single piece, which was one phrase in between quotes, and now there are multiple pieces. Each piece is stated in between quotes. You may argue that each piece is a word. Okay, so these smaller units of data are actually called tokens, and this action of going from the original sample into this other form is called tokenization. But this is done to then pass, well, there are a few other steps involved, but a machine learning algorithm is used, and the algorithm would produce an output saying, okay, the sentiment is positive. So it's kind of like the output is also a category, like a categorical variable, whether it's negative, neutral, or positive, and then the prediction here from the algorithm is that this is positive. So in summary, the data that we have been using with pandas, for example, a very common task is to use pandas to read data that's stored in a file with extension CSV, comma separated value. And once you use pandas to read this data, there is a temporary, really quick action that happens as you're reading that. You're storing that into some local variable. You create a name, and that is now an object that is known as a data frame. So data frame is another name for a matrix, but more precisely a table of data, or data frame is yet another name for an object in Python or R that is storing tabular data. And so the power and the beauty of these data frames is that, well, after doing a little bit of pre-processing, if the data is messy, you have to make sure the data is tidy. So once the data frame is storing tidy data, then you have that powerful, property that the columns, the so-called features, are of different types, but they are all interconnected. They're all the data frame as a whole is one thing, and so this is powerful in the sense that tabular data, but really in general more like there may be a mixture of categorical columns, quantitative columns, some columns that are storing text data or image data. They are all together. That's what the data frame is. And so this is also something that's known as multimodal data. And so also what we see here illustrated is that the label is a separate column. Still, it will be part of the data frame, the original data frame at least. The label is the target, is what the end goal of what we would like to predict, what we would like the models to, would like to use the models for, is to make predictions about whatever that column is describing. So that what we call label or target may be a categorical statistical variable or maybe a quantitative. So if it's quantitative, which is what you associate with regression, typically that would be a rational in the data type of a rational number and floating as a float data type. If it's categorical, then it's going to be a discrete number of categories where each category is a word. But the most common one is that there are two categories: binary, yes or no, true or false. So the label may be categorical or may be quantitative.